First thing we want to do when we get a paper is read the instructions on the front. And when we read the instructions on the front, it tells you you've got 1 hour to complete your paper, and it also tells you 2 decimal places, and your G, your acceleration due to gravity, is taken as 10. Its total mark for the paper is 50, and you get a formula sheet on page 2. A couple of things here which might be useful to you, and that is it. Okay, if we get started then, first question, tricky enough for you. First question says, identify each of the measures below as either a vector quantity or a scalar quantity. Now, one thing that always comes up is that forces are vectors. Okay, so a force is a vector. So any of the ones which are forces are going to be vectors. Time is just a scalar. Weight is a force. It's your mass times your acceleration due to gravity, but it's a force. And it's going to be a vector then. Acceleration is a vector. Mass is just a scalar. Velocity is a vector. Distance is a scalar. Tension is a force. So tension is a vector. And that is it. Okay. Question 2 is about our vectors again, but forces as vectors. And it says a body is acted upon by 3 forces, P, Q, and R, where they are vectors. Given that 2P minus 3Q is equal to R, calculate the values of X and Y. I'm going to do this as a column vector. So 2P is going to be 2X minus 2Y, and then minus 3R is going to be 6Y minus 9X, and that equals my 3Q, and then that equals R, which is 22, 24. Now I'm going to look at the I part. So the I's are in yellow. So we have 2X plus 2X minus 6Y is equal to 22. That's equation 1. And then the J's, if we look at the J's, they're going to be in the blue. Again, be careful here. I'll try not to make the same mistake. Minus 2y minus this time is plus 9x is equal to 24. That's my equation 2. I'm just going to write that as 9x minus 2y equals 24 as my equation 2. So just rearrange those so the x's are both at the start. And then what we want to do is multiply that one by 3 so that you've got minus 6y in both equations. And 3 times the 9x is 27x. 3 times the 24 is 72. I will write down my equation 1 underneath. And then we want to eliminate the y's, so we're just going to subtract. So I'm going to do 3 times my equation 2 minus my equation 1. That's going to give me 25x is equal to 50, which means x equals 2. File that into equation 1. So you're going to have 2 times 2 minus 6y is equal to 22, which means a wee bit of rearranging. That's going to be 4 minus 22 is equal to just 6y, or minus 18 is equal to 6y, or my y is equal to minus 3. So there's my x was 2, my y was minus 3. Tricky enough wee question. It says, next one, the forces of PQ are removed and replaced by a force W, where W is equal to minus 6I plus 6J. Find the magnitude of R plus W. So R is equal to, and R was equal to, we just worked R out to be 20, or they were told R was 22, 24. And your W then is minus 6. Again, I'm using column vectors. So that was my R plus W. When we add those, my R was a 22, 24. My W is a minus 6. Add those, you're just going to get 16, 30. I will write that then just as 16I plus 30J. And to get the magnitude, that's just the size of it. You're just going to square the 16. I just put those in a bracket. I always put them in a bracket in case one comes negative. Don't want to mess that up. And if you do that, you get 34. So it's just going to be 34 newtons. Find the angle that R plus W makes with positive axes. Let's just write down what my R plus W is. Again, it was 16I plus 30J. And then the angle it makes with positive axes at 16 to 30. Very bad diagram there. Clearly not. The scale doesn't matter. and we want to find the angle it makes here, so that's our theta. So tan theta is opposite, which is 30, over adjacent, which is 16. Do tan to minus 1 of that, and remember it said 2 decimal places, so 61.93 to 2 dp's. Okay, next question says A, B, C all lie on the same straight line as shown below. The distance from A to C is 200. Let me just mark that on, just in case I forget that. That's 200. And a particle moves with constant velocity and passes A, so it passes A at this point with a velocity of capital U. After 10 seconds, it passes through C, traveling at a velocity of 30. So it gets here, it's going at a velocity of 30 meters per second. Here, it's going at a velocity of capital U. Calculate the value of U. Okay, so my initial velocity, small u, is equal to big U. My distance, my S, is 200. Sorry, this is me doing from A to C. This is what I'm doing here. And my time was 10 seconds. What else do I know? My final velocity was 30. So here, what could be used? We could use S is equal to a half U plus V times T, which fill that in, that's 200 is equal to a half big U plus 30 times my T, which is 10, and that's 200 is equal to a half times 10 is 5 times U plus 30, so that's 200 is equal to 5U plus 150. Bring that 150 across, you're going to have 50 is equal to 5U, big U then is equal to 10 meters per second. Okay, right, the next bit says find the acceleration of the particle from A to C. So again, from A to C. Now what you could do is you could use the initial values to find the value of A. So you could use that. You've got your T is equal to 10, your S is equal to 200, your V is equal to 30, and you're wanting to find your A. This is one of the formulas that's not given to you, but this is the reason I like it. So S is equal to VT minus a half AT squared. That's not given to you, but I think it's a good one to know. I'll show you in a wee second. If you don't like this, I'll show you in a wee second another way of doing it, which you're going to prefer anyway. But the reason I prefer doing this is just in case I had messed this up, I'd got this wrong. That's why this is the only way of doing it, really, avoiding using the answer you've used before. But anyway, we'll see. Sometimes you can't do that anyway. So that would be, when I tidy that up, that's going to be 50A. That's going to be minus 100 is equal to minus 50A. A little bit of working out, your A works out to be 2 meters per second squared. Okay, nobody will have liked that, but anyway, we'll show you another way of doing it is just using V is equal to U plus AT. You know the initial velocity was 10. You know the final velocity was 30, so 30 is equal to 10 plus, and my time was 10, so 10A, and that's going to be 20 equals 10A. A is equal to 20 divided by 10. A is equal to 2 meters per second squared. So I know which one people are going to prefer. Next one says a particle passes through a point B with a velocity of 22 meters per second. Calculate the time taken to travel from A to B. Okay, right, we worked this out, and I think we'll have to use this thing. We know this speed here, or the velocity I should say here, initial velocity. We now know it gets to B at a speed with a speed of 22 meters per second. We don't know the distance from A to B. We do know the acceleration during that time is 2. I think that's all we know. We'll get started this. Okay, so this is me going from A to B. My initial velocity we worked out to be 10. My final velocity, when we get to B, is 22. My acceleration we worked out to be 2, and we can find, so it's again using a nice easy formula, V equals U plus AT. 22 is equal to 10 plus 2t. That's going to be 12 is equal to 2t. My t then works out to be 6 seconds. Lovely. The distance of B to C. Okay, right. The total time for this journey from A to C was 10 seconds. We now know it was 6 seconds here. So that means this bit is going to be 4 seconds. So we'll write that in first. The time, this is from B to C, the time is equal to 10 minus 6 so it's just 4 seconds. Also, the speed, it started here from B to C, it starts with a speed of 22. So let's just write that down. T is equal to, what have I just said, 4 seconds. My initial velocity is 22. It gets, the acceleration is still 2, and we'll go from that. All right, so that's what we've got, I think it is. So find the distance. We want to find the distance. So my distance is equal to, so is that right? Yep, A to B was that, so B to C then. So yep, S is equal to UT plus a half AT squared. So S in this case is 22 times 4 plus a half times my A, which is 2, times my 4 squared. And then whatever that's going to be, what's that going to be? 88. And then a half times 2 cancels out, plus 16. What is that going to be? 90, 98, 104 meters. Let me just check that. That's the sort of thing. I'm going to get it wrong. That is, of course it is. That's going to be 22 times 4 plus 0.5 times 2 times 4 squared. Do it in one go in the calculator. Smarter way of doing it anyway. Just skip that out. You would just do that in the calculator. Make sure you're going to get it right. Sort it. Okay, lovely question. Now we've got question 4 says 2 blocks, X and Y of masses, 8 kilograms and 12 kilograms respectively, are connected by a light and extensible string which passes over a smooth pulley. Block X is held at rest on a rough horizontal table. Block Y hangs vertically above the ground as shown in the diagram. Mark on the diagram above all the forces. We don't really know this friction. I'm just going to write FR, so for friction. You're going to have a tension here. You're going to have a tension here. You're also going to have an equal and opposite tension at those pulleys, which I think actually comes into play in this question. And strictly, all the forces acting on blocks. You've also got the weight, 8 G newtons. You've also got a normal reaction here. Whether or not they're really looking flat, I do not know. But I would just put it on, and you've got the weight going down here. That's all your forces. Later on, they're going to tell you this thing accelerates, so it's going to accelerate that way. Double-headed arrow with the A on it. We'll come back to that later on. Okay, the force due to friction on the block is 30. So calculate the acceleration of the block. Okay, right. So we know this thing is equal to 30 newtons as well. The friction. For the next bit, calculate the acceleration of the block. Right, can we just about see that diagram? What we're going to do is say consider the whole system, and we're going to use F equals ma. Now if you imagine this is a force that's actually getting it going, and so that's my 12G, it's getting the thing going. What's going against that? The only other force going against it, because this T, this T, this T, and this T, they cancel each other out. So the only other force going against it is the friction, which was 30. That's equal to the total mass, which is 8 plus 12, so it's 20 times my acceleration. And that is 120 minus 30 is equal to 20A. That's going to be 90 is equal to 20A. 90 divided by 20 is equal to my A. My A works out to be 4.5 meters per second squared. Lovely. Next bit says calculate the tension in the string. Okay, I'm going to look at the 12 kilograms. And what I mean by this, so looking at the 12 kilograms, if I put a wee ring around it, I'm just considering this. Okay, so for the 12 kilograms, again we're using F equals ma. 12G is getting at 12 kilograms going, minus the tension, and that equals the mass, which is 12, times my acceleration, which is 4.5. Let's just move those around. That's 12 times 10 minus 12 times 4.5 then will be equal to T. File that into your calculator, and I got bang on 66 newtons. Okay, that's what should go in down here. So we should have had in here, just so we could have seen the diagram there. And the last thing, calculate the magnitude of the resultant force exerted by the string on the pulley. I'll do my diagram up top again to show you. But what we've got here, get rid of this. If you imagine these are the forces on the pulley, this is the setup you've got here. All right, so just those forces. Oh, sorry, that's not quite right. Just those forces there. Those two forces are the ones which are acting on your pulley. So let me just cut those out. And I'll pull those down. So if we bring this down here, these are our forces on our pulley. You obviously can do it a lot easier, but that was just to make life easy for me to see. Oh, so that's what you've got as your forces on your pulley. Redraw this as, and remember the T, what was the T? Did we just work T out to be 66? So it's 66 newtons to the left, 66 newtons down, and we want to find the single force which replaces them. I'll call that my resultant. R then is equal to, by Pythagoras, 66 squared plus 66 squared, square root of that. Do that in your calculator, 93.34 newtons, and that's to 2 decimal places again. Lovely question. Okay, next one. Question 5 says a uniform rod AB of length 10 and mass 13 kilograms is attached to the fixed point on the ceiling by a light inextensible string. There'll be some tension in this string then. String is attached here at the point C on the rod where the distance AC is D and D is greater than 5. We don't know what D is, and I imagine we're going to have to find it, but that distance there is going to be 10 minus the D. Okay, and then at your A, you're going to have 16 newtons. At B, you're going to have 21 G newtons. Your centre of mass then, you're also going to have, it's a uniform rod, you're going to have this, and that's going to be 5 meters because the length of it was 10. Okay, the rod remains in equilibrium. By the way, what you would normally do in this question, it's a bit of a strange question, this one. They ask you to find the T, which is very rarely ask you to do in this sort of question. And also, in this one, normally it's easiest to take moments about this point and then just do clockwise equal to anti-clockwise. Just the way the diagram's done, it doesn't actually work out that way to be the easiest. But it's a bit unusual, but that's normally what you would do. It's not a very common thing for them to find the tension in the string. So that's all our forces marked in the diagram. Calculate the tension in the string. So you can see my diagram. All I'm going to do here is resolve vertically. The only force going up is the T. Everything else is going downwards. And that's going to be 6 times 10, 13 times 10, 21 times 10. And that is going to work out to be 400 newtons. So we've got our tension. Next bit says calculate the value of D. I'm going to do this up here. This is my part 3. We've got to find our value of D. Let me give myself a little horizontal line to help my terrible handwriting. We now know T is equal to 400. And what else do we know? Right, as I said there, normally what you would do is you take moments about this point here, about the C in this one, about where it's hanging from basically, and do clockwise equal anti-clockwise. Why it's a wee bit trickier, you'd have to find this length here from C to the midpoint, which is going to be a wee bit tricky. It's just a bit awkward. You could do it, but it's you don't have to do it. It would be easier if we just take moments about A. Because it's balanced, taking moments about any point, clockwise is still going to be equal to anti-clockwise. So here you can see if I take my clockwise, I'll do these one at a time, from A, this force here would be going clockwise. So what would that force be? It's going to be, or would that moment be, 13G times 5. What else do we have going clockwise? Going clockwise, you're going to have this one here, which is going to be 21G times 10. And anti-clockwise, we only have one anti-clockwise, is D times my T. And again, that makes it much easier doing it this way because you've got your equals D times T, and T you can see there was 400, so it makes it much easier doing that. So you could just do that. Ask me 13 times 5, 13G times 5, sorry, 21G times 10, all divided by 400 is equal to your D, whatever D works out, cheating here. What I got was 6.875 meters. I would hope that would give you the answer if you got marks, if you got that, but strictly you should give it the 2 decimal places, as it said so on the front of the sheet. Okay, I think there else should have been in there. And one more mechanics question, I think, and then we're on to some stats. Maybe I'm wrong on that, are we? Oops, sorry, nonsense. Ignore me. This is our last question. Last question, of course, is a separate paper. Apologies. Right, so you've got your last question here. This is a box on a rough of 7 kilograms lies on a rough slope, which is inclined at 35 degrees. The horizontal is shown in the diagram. The box is released from rest and begins to slide down the slope. So it's going to be accelerating down this way, and mark on the diagram all the forces. So you're going to have a frictional force, call that FR, F subscript R. Do a vertical line going downwards, that's your 7g newtons. That's your normal reaction, that's 35 degrees. And there we go, and then we can start doing this thing. So it says calculate the normal reaction. The normal reaction is this force here. It's going to be equal to this force here. So going in this direction, that's what we're going to have. So we're to get the normal reaction, we resolve perpendicular to your plane. That's how an easy way to write it. R then is equal to 7g cos 35, which worked out to be 57. So 7 times 10 times cos 35, 57.34 newtons. Again, to 2 decimal places. Lovely. Next bit says the force due to friction is 4.8 newtons per kilogram. So we'll do part 3 here. And we can see our diagram. Okay, what did I say there? 4.8 newtons per kilogram. So if we resolve, and what, sorry, I didn't read the question. What we've got to do here, apologies, is calculate the acceleration of the box as it slides down the slope. So we're going to resolve parallel to your plane, and we're also going to use force equals mass times acceleration. If acceleration is taking place, you're using F equals ma. So how this thing is getting going, we're going to ignore this force here. How this thing is getting going is there's a component of this weight here acts down the slope. All right, and that the force that's getting this whole thing going is 7g sine 35 then minus my frictional force, which was 7 kilograms, and it's times, what did we just say? I keep forgetting this. 4.8 newtons. And that equals a mass, which is 7, and then times my acceleration, and that's what I'm trying to find, times the 7. Okay, so there we have it. And all you need to do, again, don't use your calculator to work all these things out just yet. Just show you're working out. It's going to be all that divided by 7 is equal to your A. And let me just check out of an answer here, but let me just check and see if I agree with it. So we had 7 times the G, which is 10 times sine of 35, and then minus 7 times 4.8, and then equals, and then divided by 7, and I got, yep, and I got the same thing again. So that's going to be 0.935764. I'm doing a whole pile of decimal places because we may need this for the last bit, which is 0.94 meters per second squared to 2 decimal places. Okay, right, the very last bit of the question paper, it says the speed of the box when it's travelled 1.3 meters down the slope. Its initial velocity is 0, speed gets up, its distance it has travelled is 1.3. The acceleration is, and I'm copying from what I had written down earlier on, the more detailed one, 0.935764, I've still got that in my calculator, and I'm looking to find my v. So you're going to use v squared equals u squared plus 2as. V squared is equal to 0 plus 2 times my a, which is 0.935764, times my s, which is 1.3. V squared is, and what I got was 2.432987345. Square root that, and I got 1.56 meters per second. Again, that's the 2 decimal places. And just check, that's the end of the question paper. Always go back through your paper looking for any mistakes. Hopefully I haven't made any. I'm sure you will let me know if I have. Thank you very much.